Welcome back to part 2 of the Python crash course. Let's jump back to the Jupyter Notebook and get started. In part 1, we discussed all the basic data structures that Python has to offer. Now let's discuss some of the basic operators, such as comparison operators and logic operators, as well as discussing for loops and while loops. Let's start with comparison operators. Comparison operators just allow you to compare two different variables or two different numbers, two different strings, etc., and then get back some sort of Boolean value, either true or false. For example, if I want to check if it's 1 greater than 2, well, that returns false. Is 1 less than 5? That returns true. So let's walk through a couple more of these. I can do greater than or equal to. I can do less than or equal to. And then I can check for equality using two equal signs. So is 1 equal to 1? Well, that's true. And I can do the same thing for strings. Is A equal to A? Well, that's true. And note, this is case sensitive, so capital A equal to A, that's going to return false. Those are not exactly the same. And if you want to do inequality, it's just an exclamation point. So is 1 not equal to 2? Well, that returns true. They are not equal to each other. Now let's discuss logic operators. Logic operators just allow you to combine multiple comparison operations. For example, if I want to check is 1 equal to 1, well, that returns true. And if I want to check two conditions, then I just use and. And then in parentheses, I can put in the new condition. So I want to check is 1 equal to 1 and is lowercase a equal to lowercase a. Well, that's true. So for example, let me change just one of these, and that returns false. So I always recommend using parentheses whenever you use logic operators, but you don't actually need them in a lot of cases. So if I just run this, it will run fine. But I always recommend having parentheses. Makes it a little more readable, in my opinion, and it also makes sure that you don't get any errors. Okay, so that's the and comparison, or and logic operator, excuse me, and then there's the or logic operator. So a lot of times in other languages, these are either ampersands or pipe operators. Luckily for us, it's just simple English, or for or, and then and for and. And you can do more than just two, you can kind of stack these on. So we'll say and maybe, I don't know, 3 equals to 3. That returns false again, so let's change one of these to be 1. Run this, and then that's true. So that's really all we need to know about logic and comparison operators. Now let's discuss if, elif, and else statements. So these are essentially just if, else, if, and else statements. This is quite simple in Python. All you have to say is if, and then whatever condition you want to check. So for example, if 1 is equal to 1, colon, and you notice when I hit enter, I get an indentation there. So Python depends a lot on white space. So unlike other languages that will separate these sort of code blocks with curly braces, Python just uses white space and indentation. That's why a lot of times it's recommended for beginners, or a lot of people really like programming in it because this sort of white space makes things readable and makes things very simplistic. So if 1 is equal to 1, I want to print, I don't know, yeah. And then we get out yeah. So let's say if 1 is equal to 2, print yeah. If I run this cell, I don't get anything back, which makes sense because 1 is not equal to 2. So that's a simple if statement. Now let's show you an if-else statement. So I can say if 1 is equal to 2, print worked. If I want to add an else to this, then all I have to do is line up the else with that if, and else doesn't have any condition because it's kind of a last case thing. And then we'll say nope. And let's make sure that's all in a string. And then shift enter, and I get back nope. So if 1 is equal to 2, well, that never executed. So then we get else, print nope. If you want to check for more conditions, then you just add in an elif. So that's elif right there. And then you can add in a condition. And this condition doesn't need to be in parentheses. So a lot of times in other languages, you would see a parentheses here and then some sort of a condition check. In Python, you don't actually need it. Everything just works off that colon. So here I'll say elif 3 is equal to 3, colon. And note when I hit enter, there's automatic indentation there. I will print second condition true. So I run this, and I get second condition true. Great. So that's really the basics of an if, elif, or else statement. So moving along, let's talk about for loops. So for loops in Python are actually quite simple. You can for loop through a lot of different sort of sequences or objects, including lists, dictionaries, and tuples. We'll just focus on lists since that's basically what we're going to be using throughout the course as far as for loops. So we'll say a sequence, 1, 2, 3, and let's add a couple more numbers, 4, 5. So there's seq, it's just a list, and I'm going to say for item in that list, which is sequence, colon, note the indentation, and then we can do something, such as print every item in that sequence. And now that gives me back 1, 2, 3, 4, 5. Now, a common point of confusion for newcomers to Python is, does it have to be this keyword item? Well, actually, no. This can just be any temporary variable name that you want. So let's make it really obvious by calling it jelly. And if I run this, I get back the exact same result. Perfect. So I also don't actually need to use this variable. So for example, I can say for element in sequence, print hi. And then if I run this, I get hi, 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 etc. And then I can also use something like element plus elements, and then I get 2, 4, 6, 8, 10. So basically doubling each element in that sequence. So that's all you have to do for a for loop. It's just for, then whatever temporary element variable name you want there, in, and then whatever sequence you're using for that for loop. Quite simple. Now let's discuss while loops. So while loops keep running while a condition is true. So I will say I is equal to 1, and then while some condition, for example, while I is less than 5, and currently it's set to 1, so that makes sense, I will print I is curly brackets, and then I will say dot format, insert I there. And then I don't want this to run forever, so let's say I is equal to I plus 1. Then I do shift enter, and I get 1, 2, 3, 4. So what's actually happening here? Well, I is equal to 1, and while this condition is true, I less than 5, I'm just going to print out I is currently I, etc. So it goes 1, 2, 3, 4, and on that very last one, it says, okay, well now 4 plus 1 is 5, so I is no longer less than 5, it's actually equal to it, so this loop ends. And that's the basics of a while loop. Let's discuss two more things, a range function and list comprehension. Often, you'll want to quickly create a list of integers. So for example, a lot of operations, it's really common to do something like 1, 2, 3, 4, etc., and then loop through a certain number of items. But you can actually really quickly create a list that looks like this using range. So for Python 3, if I just say range of 5, it just gives me back this sort of range generator. But I can cast it into a list, and it gets me back a list of integers. And I can actually specify the starting point and the end point. So if you're ever confused on what a function actually does, you can just, again, use Shift-Tab, and it will tell you the docstring. So it's quite easy. So range, you can say stop, and it gives you back that range object. Or you could also say the start and stop. And you can even indicate a step size. So let's see that in action. I want to start at 2, and let's go to 5. So something that's kind of confusing for beginners is why is 5 not included here? Well, you can think of it as basically up to but not including 5. So it only goes to 4. So we say the stop is up to but not including that integer, that last integer. And the reason for that is because indexing starts at 0. So you can almost think of it as kind of taking away 1. All right, so that's the basics of range. And you'll commonly see range used in a for loop without this sort of list call. So you can say for x in range 5, and then we'll say something like print hi. And there we see hi, 1, 2, 3, 4, 5. Okay, so this is 0, 1, 2, 3, 4. So 4 is up to, but not including 5 there. And that's the basics of range. And we'll see it every once in a while, not too often throughout this course, but it's common enough that you should know it. Finally, let's discuss list comprehension. So list comprehension is a really useful feature of Python. Often you'll find yourself trying to build out a list. So let me show you an example of that. I'm going to create a list, 1, 2, 3, 4, 5. And then I will say out is equal to an empty list, so just those square brackets. And I'm going to say for num in x, take out and append that number squared. And then outside of this for loop, note my indentation, how it's lining up with that for. So once that for loop is done, I'm going to print that out list. So let's run this. And we get what we expect, 1, 4, 9, 16, 25. So what am I doing here? Well, I have out as my empty list, and I'm saying, okay, for every number in that x, append the squared number of it. And then at the end, print out that entire list. So 1, 4, 9, 16, 25. This sort of action is so common in Python to build out a list this way that they've actually created essentially a shortcut, a way to flatten this out into what's known as a list comprehension. So I'm going to convert this sort of for loop into a list comprehension. And the way we do that is we say put everything inside these square brackets. And then we start by saying num to the power of 2, or whatever you're trying to append. And then we say for num in, and then the iterable was x. And if I run this, this gives me back the exact same thing that this for loop did. So you can think of it as just another way of writing out a for loop that particularly creates lists. So if you ever find yourself constantly appending to a new list inside of a for loop, you may want to consider list comprehension as a possible solution just to flatten this out. As far as readability is concerned, for newcomers, this is not as readable as a for loop, but once you end up working with Python a lot, you'll end up preferring list comprehension. It's slightly faster. There's a very tiny performance boost there, but for certain situations, it's negligible. Okay, so that's really all we want to discuss for part 2. Coming up next, we'll discuss functions, lambda expressions, and then methods as well. Okay, thanks, and I'll see you at the next lecture. Welcome back to part 3 of the Python Crash course. We're going to end things here by talking about functions and some special methods you can use off of Python objects. Let's jump back to that Jupyter Notebook and finish up. Alright, let's start off by talking about functions and how you can create your own custom functions. The key word when creating a function is def, and then whatever you want to call the function. So we'll say my underscore func for func. And this is going to be a really simple function. It's not going to take any parameters. We have a colon there. And then whatever you want to have happen when you call the function. So for example, print hello. And then make sure to run this. So now the function's been defined. I can see here the cell's been run. And then I can actually call my func. And I see hello back. Now a common point of confusion sometimes is you'll just type my func, run this, and it will report back what the function actually is. So it'll say, oh, my func, well, that's a function. It's under the main file, .myfunc. What you actually want to do is if you want to execute the function, have those open and close parentheses there. If you would like to add parameters to a function, for example, let's give a parameter name, then it will intake, for example, hello, and a simple way I can pass that in is plus name. So now I'm going to run this, redefine it, and then say myfunc and pass in Jose. If I run this, it says hello Jose. So what that's doing is concatenating these strings together. So that's a little special method you can use for strings. And I can add a space in there, run these two again, and now I see hello Jose. If I don't actually provide one here, I will get an error. It'll say type error, and it'll actually say, hey, I'm missing one required positional argument called name. If you want to have a default parameter or argument value, you can just say name is equal to, and we'll say, for example, no name. And then I'm going to run this. And now, if I just pass this in with Jose, it will still work. It'll say hello Jose. But if I, for some reason, forget, it's going to go to the default value. So I can run this, and it'll say hello, no name. And that's the basics of functions. And real quickly, if you want to have a docstring in your function, you can do it with a set of triple quotes. These can be either double or single. And this is where you can describe what the function does. So I can say something like, this prints out the username. And then I'm going to do Shift Enter to run that. And now with my own function, I can do Shift Tab, and it'll say the signature of the function and then the docstring. This prints out the username. So I can see here that it actually looks for the documentation string for this function whenever I call Shift Tab, which is kind of a nice feature. All right, so let's actually show you one last function that will kind of show a more realistic example. So I'll say def square, and it takes in some value x, and then it's going to return x. So what's the difference between print and return? So print just displays the actual value. Return allows you to save the actual object or whatever the function happens to do and save it to a variable. So my little function here, square, is going to take some sort of number x, and then it's going to return the square of it. So I'm going to say result is equal to square of 2. And then if I check on my results, I notice that it's 4. So with the return keyword, I can actually save this as a variable. If I just printed this, so if I just said print and put that there, then what would have happened was I would get none back. So if I rerun these, I get back nothing as a result. So notice it says result is equal to square 2, and when I run this, it prints it out. But then when I ask for what result was, it's actually none. And if you check the type of result, it'll say it's a none type. The reason for that being is that it only printed out the value 4, it didn't actually return it. And the only way I can save it is if I return it. So the only way I can do the assignment to a new variable is by using that keyword return. And then rerunning all this, notice if I run this again, I don't actually see the printed out result because I was returning it in order to save it to this variable result, which means I have 4, and if I check the type of result now, I get this integer type. Okay, now let's discuss lambda expressions. Lambda expressions is just a way you can quickly type an anonymous function. That's also another name for it. Essentially, if you only plan on using a function one time, maybe you don't want to rewrite the entire function, give it a formal name, use the def. You just want something kind of quick and easy. So the way you can do that is, for example, if I have def, we'll call this times 2. It takes in some variable, var, and then it's going to return var times 2. So for example, I can say times 2, and notice I can use tab to autocomplete that, so it's a little faster. So it says times 2, and it returns 20 for me. Notice that it's returning it, not printing it out. That's why I have that a little out next to that cell. The way I can use a lambda expression to rewrite this is the following. Use the lambda keyword, the input, colon, and then you want what you want the output to be. So for example, var times 2. And now this will behave really similar to the function. For now, it's not really clear how to use these. We need to use these along with another outside function. So we'll talk about this later on in the course when it shows up, but I just want you to be aware of what the lambda expression is, essentially an anonymous function. So it's a different way of rewriting this whole thing in just one go. But the issue here is I can only call this one time. I don't have a name assigned to it. So what's the actual relationship between this and this? Well, I can kind of convert this function to show you. First thing I need to do is take away the name, take away this def keyword, replace it with lambda, take away these parentheses, take away the return keyword, and then put it all in one line. And that's how you can convert a function to a lambda expression. And later on throughout the course, if we ever use a lambda expression, I'll touch in a little more detail on how we actually use this. I just want you to see it for now. All right. Moving along, I want to talk about a few methods that are going to be useful to you throughout the course. So methods on strings. I'm going to create a string called st, and it's going to say, hello, my name is Sam with a capital S. If you ever want to lowercase everything in a string and just say s.lower, close parentheses here, and it returns back everything lowercased in that string. So notice here, s on Sam has been lowercased. We've seen upper before. It's the exact same thing, except it uppercases everything. A really useful method is split, which is going to split by default on white space and return a list. So it splits that string into a list based off the white space. If you actually want to split on a particular string value, you can clarify that as well. For example, I'm going to create a tweet here, and later on we'll see how we can do Spark streaming for tweets. but I'm going to say hello, hashtag sports, run that. And then I'm going to, if I just say split, by default, it splits on white space. So it splits hello and then hashtag sports. But maybe I actually want to split on hashtag, so I want to analyze Twitter somehow. Well, I can just pass in hashtag there, and then it's going to split on the hashtag. And notice how now the hashtag is no longer in this list because that is what was split on. And then if I want to grab the actual item from this that was in the hashtag, assuming that the hashtag is all the way at the end, I could just say something like -1. And then that returns the string sports. Obviously, not every case will have a hashtag all the way at the end of the string, but this is kind of just to show you a little more realistic of an example of how you can actually use split. Okay, a couple more things I want to show you is how you can grab the keys and items of a dictionary. So just quickly now, if I create a dictionary with K1, V1, so key 1, value 1, and then maybe K2, V2. If I want to grab all the keys in the dictionary, I can just say d.keys, and I get this dictionary keys where I see K1, K2. If I want to grab all the items, I can just grab these kind of tuple item pairs. So K2, V2, K1, V1. Note that the order here is not retained. Again, dictionaries do not retain any order. We won't actually see these basically at all throughout the course, but just something to be aware of in case while you're using Stack Overflow or something, you kind of run into these on your own. Finally, I want to show how you can pop something off of a list or check if something is inside of a list. I'll say my list is equal to 1, 2, 3. If I want to grab and remove the last item in a list, I can say a new variable last is equal to my list and then say .pop close parentheses. And now if I check my list, it's missing that last item, that number 3, and I've saved it to this variable last. So that's how you can remove an item from a list, at least the last item. If you want to remove an item at a specific index, you can just pass that into pop. So for example, let's redefine my list again as 1, 2, 3. So if I check my list, I have all 3 numbers there. And then I want to pop off the first element. Well, I'll say pop, and then pass in the index 0 to indicate that I want to pop off the first element. And I'm going to save that as now first. Run this. I can check my list, just have 2 and 3, and then I can check first, and it's 1. If I want to check if an item is inside of a list, I can just use the in operator. So I can say x in 1, 2, 3. That returns false. If I ask for 1 in the list 1, 2, 3, that returns true. So I could also say something like 2 in my list that I defined earlier, and that also returns true because my list is now 2 and 3. Coming up next, we have a really quick review exercise notebook that's optional in case you just want to clarify and make sure that you really understood everything we were talking about here. Totally optional, you don't have to do it, but it would be a quick review just to confirm that you understood everything and you're ready to go to talking about Spark and Python on data frames and all that cool stuff. Thanks everybody, and I'll see you at the next lecture.